some of the other things I've got prepared. Mentioned the Spitfire in the description for this webinar, so we could move on to that if you
Absolutely.
want.
I'm
Pretty good.
I've got a little caveat here, right? So
Mm,
um I may not sound English. I'm not. I'm originally from South Africa, but
mm,
my grandfather is a Geordie. Can you believe it? And
mhm,
in World War II, he flew Spitfires. He was a
mm.
squadron leader, and I, long history behind that, but he was shot down in Holland and survived, and there's this amazing history behind it. And so Spitfires has a special place in my heart, mate, which
Ah,
I'm trying to say. So
yeah,
yeah, let's hear about it, because I think your external work is just as interesting as your internal stuff that you do
yeah,
at the university.
absolutely. Yeah, it tends to be quite a lot grander. um, but yeah, I'll share that because yeah, after scanning it, it's got kind of a special place in my heart as well.
Brilliant.
Yeah, so I managed to combine it all finally. Just kind of the raw scans. Um, but yeah, this took probably about 5 or 6 days total. We did it with the Black Elite, so we had to put those markers all over it every time we scanned it. It was initially I thought it was kind of silly to do, like we should probably do this some other way. I think we tried with the Faro focus first, but yeah, it just didn't quite capture it right because this is where the Spitfire is. It's in a big room with like glass windows all around, so the lighting kept changing. And yeah, since it's kind of image based, I couldn't get anything to align with it. So we went in with the HandySCAN and just tried to capture it in as good a detail as possible. We used like the 1mm resolution, though to get it loaded in here, I've decimated it down a bunch.
Yeah,
uh,
big file, I
yeah,
bet. Yeah.
yeah. I think the most I could get together in one VX Elements session was this. So I've had to export them out, decimate them, I've aligned them in Cloud Compare, and then recombine them here in Blender. So this is like one of the scans would have been just the bottom of the wing, um, and that would have almost like capped out the RAM on the laptop we've got for the scanner here. So yeah, new file, top of the wing. Make sure we've got enough overlap on it. Um,
It's a
yeah.
you kind of, there's two things I've just picked up on there. So the first one was you mentioned using other scanning technologies such as
Mm,
lidar based systems, um, and one of the things that is often very important to consider when you're looking at 3D scanning, and even if you bring it into your own university or into industry, is considering the application and the requirement for what you're actually wanting to measure or scan. And
yeah.
often you can kind of pick the wrong tool for the job, and your experience there of trying it with the lidar and finding that the lighting environment's a problem.
Yeah, for
um,
sure.
and also kind of your level of detail. A lidar might not have that level of detail that you can pick up with a handheld laser
Oh,
scanner.
absolutely. We wouldn't get all the rivets come through on it. Yeah, that's for sure.
And that just takes a little bit of experience. And I think,
Mm,
what's really important in that kind of scenario is talking kind of your experts that do it, but then also, as the more you scan, I'm sure with this approach here with the Spitfire, you would have very quickly picked up the HandySCAN as your first choice
mm.
when you do it again. Do you want to just talk me through the kind of, obviously being commissioned to do this? How has that come about? What was the idea behind scanning the Spitfire?
Um, I think we'd had projects with the museum, the Potteries Museum up in Hanley here in Stoke. It's so we had the VR students had a task to scan various artifacts from that museum before. So we brought in things like gas masks and old like medical boxes and things like that. And yeah, part of their course was scanning those in various ways and then reconstructing them. And actually, those went back into the museum um, where they have a like a touch screen, which has these digital recreations of them that the students have
Amazing.
made.
Yeah.
Yeah, so that's all in the same room as this Spitfire. Um, and I think something just led on to them doing this, and they gave us a bunch of money for it. This was all organized by the uh, one of the VR course leaders at the time, Yankarenko. Um, yeah, and he got us in there, scheduled these scanning sessions with this, and I believe he took the data in the end and produced something for them. So I've just kind of picked up the what we had because again I never got the final thing from him and just kind of put it all together here, mostly out of interest, but also yeah, something really cool to show off in this
Yeah,
webinar.
I mean, it's very, you kind of forget the scale, don't you? Looking at
Mm.
literally a small screen and a little model, like it's like,
Oh,
oh,
absolutely.
that's great, but actually, this is a full blown plane, which is really really incredible. And I think what I love hearing about this example is how Staffs is giving back to the surrounding area. And I think, Staffs Uni was, I think, you established sort of 1906 around sort of mining and science and things like that back over 100 years ago.
Yeah, it was a
And so to
polytechnical or
have,
something. Yeah.
yeah, and it's really amazing to see how Staffs has developed over the last sort of 20, 30 years, especially once it became established university. And the
Mm.
kind of, students that you have coming out of it. I'm one of those students. My wife
Mm.
was one of those students. And it's amazing to see how you guys are driving virtual reality and sort of these immersive technologies to the forefront. And in examples like this, critical from an heritage point of view,
Mm.
using the data to share with other museums, but also preserving that heritage of what was a Spitfire back in
Yeah.
World War II. Really important historical piece of information, which will now be forever stored. Um, whatever happens to that plane doesn't matter. There will be a digital copy of that plane somewhere now in existence, which is
Yeah,
fantastic.
absolutely. I'm not sure I'm not sure a higher resolution scan of a Spitfire exists to my knowledge. I'm not sure if anyone else has done kind of the same thing. I think that was kind of the what definitely Jan was excited about to do. Is like, yeah, no one else is probably no one else is going to have done this. Um, yeah.
Yeah, super exciting.
Interesting.
And we do a lot of aerospace stuff ourselves. And
Mm.
I've had the privilege of working on some of the Red Bull air racing series, where they're kind of racing planes of this size. Obviously, not Spitfires because that'd be crazy to do that. But looking at smaller planes, MXS specials, etc. And um, one of the use cases we found through that was actually creating that digital record with all the surface data allowed you to do fluid dynamics and basically your wind flow over the plane. And one of the hardest things in aerospace is working out your plane. If we're not talking about a car, right? There's complexities around Formula One, for instance, of a car driving around a track.
Mm.
But you're always driving around in one axis, right? You're always driving on a surface. You're never going to go up and down. And when you introduce planes and you introduce the complexities of airflows and temperature and the fact that you're in a full 3D environment with 6 degrees of freedom, having data of your aircraft becomes really, really important to be able to work out your airflow dynamics.
Yeah.
Is it the most efficient if you have your wing flap in this position or in this position, that kind of thing. And so, um, yeah, there's so many use cases. What's exciting that I'm enjoying this morning is seeing all the different examples you're bringing from just a couple of examples
Yeah.
already. Yeah, it's fantastic.